All right, let's look at two examples. One, well, I'll end up working them both out. Okay, but with the first example, you can watch me work through, and then you can do the think, pair, share on your own and check your think, pair, share solution with this solution down in the lower right-hand corner. And if you got it right, you can skip the video, the rest of the video. But if you want to watch and see how I did it, uh, you can just resume watching. All right, so let's look at this first example. So determine the exact values, and when we say exact values, we mean fractions, of all six trigonometry ratios without the use of a calculator. So given that theta is equal to 3 pi over 4, determine cosine, sine, tangent, secant, cosecant, and cotangent of theta. Okay, well, first thing we need to do is, figure out, well, where is this angle? All right, so theta equals 3 pi over 4. And let's see here, if we do a quick little drawing of the unit circle, 3 pi over 4 is over here in quadrant 2. So that's theta. And 3 pi over 4 will be this coordinate. So we've got positive x, positive y, and negative y. So this coordinate will have a negative x and a positive y, which has the coordinates of negative square root of 2 over 2, square root of 2 over 2. So this is, where memorizing the unit circle really comes into play. You don't have to look it up. You just know it. Okay. So we got that. So we know that, theta is in quadrant 2, and that in quadrant 2, x is going to be negative, and y is going to be positive. All right, let's find the first one. So cosine theta. So cosine theta is going to be cosine of 3 pi over 4. So this is kind of asking, what is the x value at 3 pi over 4? And if we come over here and we look at our x value, it's the square root of 2 over 2. Negative square root of 2 over 2, sorry. So that's what the cosine of the angle is. Negative square root of 2 over 2. Now let's go ahead and do secant, right? Because secant is the reciprocal. Oops, apologize for that. Secant is the reciprocal. So secant theta is going to be the reciprocal of cosine. So all we need to do is take whatever cosine is and flip the numerator and denominator. All right, but we don't want to leave a fraction with a square root in the denominator. So we're going to have to multiply numerator and denominator by the square root of 2. And that'll give us negative 2 square root of 2 all over 2. So secant theta is equal to negative 2 square root of 2 all over 2. Oh, I just noticed something. Yeah, the 2's cancel. Okay, so I need to revise that. There we go. secant theta is just negative square root of 2. That's really sloppy. Come on. That's better. All right, now let's look at sine. So we're going to have sine of 3 pi over 4. And what this is asking us is, what's the y value at 3 pi over 4? And so the y value is the square root of 2 over 2. And that's positive. So there's the sine of the angle. And let's do the reciprocal. So the cosecant is the reciprocal of sine. So we just need to flip numerator and denominator. Can't have square root of 2 in the denominator. Twos will cancel. And cosecant theta is going to be equal to positive square root of 2. All right, now let's figure out tangent. Let's start over here. So we want the tangent of 3 pi over 4. So tangent is going to be sine of 3 pi over 4 over cosine of 3 pi over 4, which is basically the y value over the x value at that point. So what we have is a positive, the value of y is positive, square root of 2 over 2, all over a negative square root of 2 over 2. And you can see that these square roots of 2 are going to cancel out, leaving you with just -1. So tangent of 3 pi over 4 is just going to be equal to -1. And let's do the reciprocal of that. So cotangent of our angle is equal to 1 over tangent of our angle. And so, we can just think of -1 as -1 over 1. But if you flip the ones, it doesn't make a difference. Still -1. So that's what the value of our reciprocal to tangent is. The value of cotangent is also -1. Now let me do a little bit of an extra thing here. And let me erase some of this stuff. Okay. And let me extend this out a little bit more. Extend this out a little bit more. And so if I draw the line tangent through that point, and so we have where the tangent intersects the x-axis there, and where the tangent line intersects the y-axis there. And remember, this value here, that is the tangent of our angle, and this value here is the cotangent of our angle. And give me some latitude here, because this was just a sketch, okay? But given this sketch, you can see that the length of this segment is equal to the length of that segment, right? The cotangent has a length of 1. Okay, we have to, because we're talking about distance, we don't have negative, okay, but it's a length of 1. And our tangent also has a length of 1. And the other thing you may have noticed is that because we're dealing with a unit circle, that's also the same as this length, which is the radius of a unit circle, and the radius of a unit circle is 1. So all three of those lengths are equal. So you can see how our angle changed the geometry of these 6 trig functions and produced a isosceles triangle where we've got a 45-degree angle there, 45-degree angle there, and a 90-degree angle there. And with these two bottom angles being 45s, the length of this side is equal to the length of that side. So if this is 1, this is 1, and the length of that one is also 1. So it's pretty neat, how all of that works out. Okay. But you can do all this stuff without really referring to this geometry part, but the geometry part could help you understand it as well. All right. So this is how we determine the exact values. Okay, the exact values, which are fractions. Well, fractions where necessary, of all 6 trigonometry ratios. And we didn't use a calculator for this. So do the same thing here with 4 pi over 3. So pause the video now and give it a try. Okay, we're back. So let's look at 4 pi over 3. So we'll just kind of draw a unit circle really quick here. Now, since the numerator is 1 more than the denominator, that actually tells us that we're going to be in quadrant 3. So we're going to be somewhere right about here. So we're going to go all the way around, and that is our angle theta. Okay, so our angle is in quadrant 3. And what that means is that our value of x should be negative, and our value of y should also be negative. All right, let me erase this because it's kind of in my way. All right, so what are the coordinates at this point? Well, it looks like as I come down from here, this is going to be at negative 1/2, and then negative square root of 3 over 2. And again, it's like, well, how did I know that? Just by looking at that rough picture I just made. It's because I have the unit circle memorized. Okay, and if it's not something you have memorized yet, you need to keep working on it because it's important to memorize those values and be comfortable with them. All right. So let's look at cosine theta, or the cosine of 4 pi over 3. So that's asking us what is the x value at that point. It's negative 1/2. So there's that one. Let's go ahead and do the reciprocal. So the reciprocal of cosine is secant. And that's, of course, 1 over cosine. So we just take numerator and denominator and flip them. So that gives us negative 2. So the secant 4 pi over 3 is negative 2. Okay, let's look at sine of 4 pi over 3. Well, that's asking us what's the y value at that point. Y value is negative square root of 3 over 2. Yeah, I just noticed I made a typo there. So this is negative square root of 3 over 2. All right, so I'm kind of noticing here that I got my signs wrong. All right, I'll have to fix that. So I apologize if you did this and you wondered why your signs were off. You know, I just realized that I made a typo mistake down here. Okay, so, but these values of negative here are correct because we are in quadrant 3, and the value of x should be negative, and the value of y should also be negative. So that looks right. All right, now let's do the reciprocal. So the reciprocal of sine is cosecant. It's equal to 1 over sine of our angle. So we're just going to flip numerator and denominator. Can't have square root in the denominator. All right, so the cosecant is going to be negative 2 square root of 3 over 3. So it looks like all of my values down here, I think, are going to be wrong by negatives. Each of these should be negative. All right, let's do the last one. So that's going to be tangent and cotangent. So tangent, 4 pi over 3, is going to be whatever the sine of 4 pi over 3 was over the cosine. And our sine was negative square root of 3 over 2, and the cosine was negative 1/2. So a couple of things. Negative divided by negative is going to be a positive. These 2's are both in the denominator, so those will cancel out. And that's going to leave us with just a positive square root of 3 over 1, or just square root of 3. So tangent of 4 pi over 3 is a positive square root of 3. So that one was correct. Okay. All right, and cotangent of 4 pi over 3 is going to be equal to 1 over tangent. Okay. But let me just give this opportunity to maybe say there's another way we could write it. Because remember that tangent and cotangent, they are reciprocals, right? Which means we flip numerator and denominator. So actually cotangent, we could write it as cosine of 4 pi over 3 over sine of 4 pi over 3, right? That's another way of writing cotangent as a reciprocal of tangent, just by flipping the numerator and denominator. And so cosine, we figured out, was negative 1/2. Sine was negative square root of 3 over 2. And just like we said before, negative divided by negative is a positive. The 2's in the denominators will each cancel. That's going to leave us with a positive 1 over square root of 3. We don't want square root of 3 in the denominator. So this is going to leave us with a square root of 3 over 3 for the cotangent of the angle. Okay, so what I need to do is I need to come in here and just change these to be negative, negative. That was positive. It needs to be a negative 2 and a negative and a positive square root of 3 over 3. Okay, so I apologize for that mistake. But I realized it once I started doing it that this is correct. That was just a typo. All right. Let me know if you have any questions.